Hey, page 15 and 16 of differentiation. Here we're working on some word problems, and it's very likely that one of the problems that appears on the test is going to be like this. The volume of water in container, V centimeters cubed, is given by the formula V equals 100 plus 2t plus t cubed, where t is the time measured in seconds. How much water is in the container initially? Okay, so basically they're saying at time equals 0, like initially time equals 0, what's V? So V is equal to 100 plus 2 times 0 plus 0 cubed, which is equal to 100. So the volume is equal to 100 in the beginning. Okay? How much water is there in the container when t equals 3? Okay, so what about when t equals 3? What is V equal to? Well, then it's equal to 100 plus 2 times 3 plus 3 cubed. So that's equal to 100 plus 6 plus 27. So that would be 133. Okay. What does dV dt represent? It's the rate of change of water in container. Okay. Find the value of dV dt when t equals 3. Okay, so I guess the first thing we need to say is what is dV dt? dV dt is the derivative of v. So let's see, the derivative of 100 is 0, derivative of 2t is 2, the derivative of t cubed is plus 3t squared. So we've already figured out what dV dt is in terms of t. Now what about when t equals 3? What is it equal to? Oh, well then we could just substitute. It's 2 plus 3 times 3 squared equals 29, because this is equal to 27. Use the answer to B and D to explain what is happening to the volume of water in the tank. Let's see. In B, we said that when t equals 3, the volume is 133. When t equals 3, we said the dV dt is 29. So we could say tank has 133 centimeter cubed. Volume is increasing at 29 centimeters cubed per second. Okay, so that would be part E. Okay, number 3. The weight of oil in a storage tank, W, varies according to the formula, okay, where W is measured in tons and T is the time measured in hours. Okay, find the weight of the oil in the tank at T equals 1. So again, just like we did last time, we said we substituted T equals 1 in there. We get 640 divided by 1 plus 40. So that is equal to 5 plus 640 plus 40, which is 685. Find dw dt. So then we just find the derivative of this. So the derivative of 5t squared is 10t. The derivative of 640 over t is 640 times negative 1 t to the negative 2. And the derivative of 40 is 0. So I get 10t minus 640 t to the negative 2. Okay, and then it says find the rate of change of the weight of oil in the tank when t equals 3 and when t equals 5. So that just means we take the dw dt expression and we substitute in t equals 3 and t equals 5. So let's see, when t equals 3, it would be 10 times 3 minus 640 over t squared, which is 3 squared. Okay, so that would be 30 minus 640 divided by 9. And then in the other case, it would be t equals 5. When t equals 5, then we substitute 5. So 10 divided by 5 minus 640 divided by 5 squared. And let me solve both of these. So at t equals 3, dv dt is equal to negative 41. And at t equals 5, dv dt is positive 24.4. What does your answer to C tell you? Well, it tells me basically that at t equals 3 seconds, we are losing oil from the tank. And at t equals 5, then we are increasing oil. Okay? And what about E? Find the value of t for which dw dt equals 0. So when does this expression, dw dt, when does this equal to 0? The easiest way to do that is with the calculator. So I'm going to type this equation in. So I just typed the equation in the calculator, except for t I put x because the calculator only knows x, right? 10x minus 640x to the negative 2. I'm going to graph it. And they said, when is dw dt, or this equation, equal to 0? Well, it's obviously equal to 0 right there. Okay, so maybe we can find it using second table. And yeah, we can. So right at x equals 4 is when it's equal to 0, right? So interpret your answer to E. I'm sorry, it's not x, it's t, right? Because we changed our t's to x's. So at t equals 4, dw dt is equal to 0. So interpret your answer. Basically, at t equals 4, tank is neither increasing or decreasing, or nor decreasing oil level. Okay. 5. Water is flowing out of a tank. The depth of the water, y, at time t is given by 500 minus 4t minus t cubed. Find the rate at which the depth is decreasing at t equals 2 seconds and at 3 seconds. Find the time at which the tank is empty. Okay, so this is the level of the water in the tank. Let's find the rate at which the depth is decreasing or increasing. It would be y prime equals 500, derivative of 500 is 0. Derivative of negative 4t is negative 4. Derivative of negative t cubed is negative 3t squared. Okay, and then we want to know when this rate is, find the rate at which the depth is decreasing at 2 and at 3. So we want to know, okay, so t equals 2, what is y prime? Y prime is equal to negative 4 minus 3, 2 squared, right? And so that's equal to negative 4 minus 3 times 4, which is minus 12, negative 16, okay? So at t equals 2, the rate it's decreasing is negative 16. T equals 3. What's y prime? Y prime is equal to negative 4, negative 3, 3 squared. So it'd be negative 4 minus 27, which is equal to minus 31. Okay? Find the time at which the tank is empty. Okay, tank is empty. That would mean that the depth, y, is 0. So when is y equal 500 minus 4t minus t cubed equal to 0? Now this is not a simple problem. You would definitely want to use a calculator to do this, so I'm going to type it in the calculator. So when is this expression equal to 0? Graph it. Wow, there it is right there. Let's see if it's easy to find. We'll just do second table and see if we can see when y equals 0. See, it seems to be getting smaller. Oh, there we go. Okay, not really easy. So now what we could do is use the 0 function. So we could do second calc, where it's like, when is this function equal to 0? Well, we have the 0 function. We could say 0, and then we just say left bound. I don't even see where that is. Okay, okay. Right bound. Go way to the right. Way to the right. Can't even see where it is. Okay. There we go. Okay, so the answer is t equals 7.77. Okay, and not much way to find that besides the calculator. 7. Weight of the oil in the storage tank W varies according to the formula 10T plus 135 divided T squared plus 4, where W is measured in tons and T is the time in hours. Find the rate at which the weight is changing after 2 hours. Okay, so let's see. They want the rate again, so we do need to find the derivative of that. So it would be 10, we could say W prime is equal to 10 plus 135 times negative 2 times t to the negative 3, and the derivative of 4 is 0. So if we want to simplify that, it's 10 plus 135 times negative 2, so that would be negative 270 t to the minus 3. Okay, that's the rate. So first it says, find the rate at which the weight is changing after 2 hours. So when t equals 2, what is w prime? It's equal to 10 minus 270 times 2 to the negative 3. Well, 2 to the negative 3 is like, 2 to the third in the bottom in the denominator, and 2 to the third is 8. So let me figure out what this is for you. 270 divided by 8 is 33.75. I'm going to subtract that from 10, so that'll give me negative 23.75. So it's saying, find the rate at which the rate is changing after 2 hours. It's negative 23.75 tons per hour. Find the value of t for which dw dt equals 0. So when is 10 minus 270 divided by t cubed equal to 0? Now again, the best way to do this is with the calculator. So I'm going to type it in the calculator. Okay, so I typed 10 minus 270 divided by x cubed into the calculator. If you want to, you can put parentheses around here, but in this case it's not necessary because PEMDAS works in our favor. I'm going to see when this is equal to 0, and maybe we'll be lucky and it comes out in the second table. Hey, it did. It's at 0 when x equals 3. So when t equals 3, w prime is 0. Okay, so that's the answer to B. If it wasn't so nice, then we could have used second calc 0 to find that. Okay, last problem. A company's profit, P, depends on the amount of product it makes, X. So here is the function. P is measured in thousands of dollars and X is measured in tons. Okay, so first it just says finds P0 and P5. That's easy, right? You just like plug in P0. You just plug in 0 here. So it would be negative 10 times 0 plus 40 times 0 plus 10 times 0, a bunch of zeros, equals negative 15. Okay. P5. So we would say negative 10, 5 cubed, plus 40 times 5 squared, plus 10 times 5, minus 15. And I'll work this out for you real quick. Okay, so I just multiplied this out with the calculator. I got negative 215 for the answer for P of 5. Now it says find dP dx. So I'm going to find the derivative of this. So it would be p prime, right? And p prime would be negative 10 times 3x squared plus 40 times 2 times x and 10. And derivative of negative 15 is 0. Okay. So we have negative 30x squared plus 80x plus 10. Okay, and then that's the answer for B. C, it says find the value of P and dP dx when x equals 2 and when x equals 3. Interpret your answers to C. Maybe the easiest way to do this is to just put both formulas into the calculator, and we'll let table do the work. So I'm going to do that. Okay, so I take the original function and I put it in for y1, and I take the derivative function and I put it in for y2, and then I'm going to look at the table, and it asks me what are the values for p and dp dx for x equals 2 and x equals 3. So let's see, when x equals 2, p equals, and then I'll just scroll down so you can see. So when x equals 2, p equals 85. P prime, or dp dx, is equal to 50. When x equals 3, p equals 105. And dp dx, or p prime, is equal to negative 20. Okay, and that's the answer for C. D, interpret your answer to C. Well, when it makes two products, which is x equals 2, then the profit is $85,000, and the change in profit is plus 50K. Okay, and then when you have three products, actually it's not three products, it's 3 tons of products. Okay, 2 tons products, 3 tons of products. So when there's 3 tons of products, then profit is 105K, and the change in profit is negative 20. Okay. What about E? Find the value of x and of p for which dp dx equals 0. What is the importance of this point? Okay, so when does the change in profit equal to 0? And if we look here, can we find a point where y2 is 0? Let's see. It looks like there's one here between negative 1 and 0. Is there another one? And there's one here between 2 and 3. Okay, so how are we going to find these 2 points? Well, let's take a better look. We're going to do zoom fit, which is 0, just to graph this a little better. Okay. All right. So that first one is the function, and then this one, this parabola, is the dp dx. Okay. Okay. So let's see. When does dp dx equal to 0? So we couldn't see it with the table. Okay. So we're going to use the second calc 0 function to find it. Now it says, do you want to use the y1 function? And we don't. We want to use the y2 function. So I use the up arrow to change it to the y2 function. Now the left bound, I'm going to make it 0, 10, and the right bound, I'm going to say enter, and then the right bound, I'm going to make it over here. So I can already see that it's already past the 0 point. Okay, that's fine. Okay, so one of the zeros is x equals 2.79. Okay, and then actually there's one other x. It's over here on the left, but it might be negative, so that wouldn't make any sense anyway. But let's see, second calc 0. And then the left bound would be way over here. Oh, I don't want that. I want the other function. Okay, left bound, right bound. The right bound, I'm going to put it right in the middle about that. Okay. Okay, here's the other 0. The other is the negative 0.1196. And yeah, this one doesn't make any sense because that would be negative tons of products. Doesn't make any sense. So the one that makes sense is the 2.79. And so let's see. What if we did trace and we did 2.79? What would be the value of P at that point? It would be 107. So P is 107. And what would be the value of P prime? It would be, I'm going to use a little trick and use the table function to find this value. I'm going to change delta table to 2.79, and then it's going to find exactly y1 is 107 and y2 is negative. So P prime is equal to negative 0.323. Okay, and so what is the importance of this point dp dx equals 0? Well, this happens to be the optimum profit point. Okay, so like this is when the change in profit is 0. So if you go to the, and I'm gonna, to make it a little easier, I'm gonna turn off this function here. I'm just going to show the original function. So now I'm just going to graph the original function. And maybe we're going to zoom in a little bit just so that you can see what it looks like. Zoom. Actually, I'm going to do window. I'm going to do y max is going to be like 0. Or y min is going to be 0. And y max I'm going to put like 200. And then I'm going to graph. And then we're going to get a better idea of what it looks like. Okay, so the dy or the dp dx equals 0 point is actually this point right here, right? And I'm going to show you that. I'm going to go trace 2.79. There it is, see? So the significance of this point is that it is the optimum profit. So this is like the most profit you can get per ton of product. So that's the amount of product you should make in order to make your factory or whatever the most efficient.